Finding inverse functions with Adam Maths Tutor. Here's the beginner question, one of the easier questions that you're likely to find on this topic. A function is a rule that maps an input, usually denoted as x, to exactly one output, usually denoted as f of x. For example, here we have f of x equals 2x minus 3. The inverse function is represented using this notation. This is not to be confused with and is not the same as the reciprocal 1 over f of x. It's not raised to the power of negative 1 and is just the notation that we use to represent the inverse function. Similar to how we would have sine to the negative 1 is actually the inverse function of sine. The inverse function essentially reverses the effect of the original function. If f of x maps x to y, then the inverse function maps y back to x. We can use this to help us find the inverse function. If we start by replacing f of x for y, and each of our y values or y coordinates are found by mapping x using the rule 2 lots of x minus 3. Since I'm now mapping y back to x, I want to do the inverse and change the subject, but I'll need my function to be in terms of x. So we'll want to start by switching or replacing x and y. So I'll rewrite it as x equals 2 lots of y minus 3. And now I'll need to do the reverse function, or the inverse, which can be found by making y the subject. Adding 3 to both sides will give me x plus 3 equals 2y. And dividing by 2 on both sides is x plus 3 over 2, which is equal to y. And this part that I've made equal to y is my inverse function in terms of x. So the inverse function of x is x plus 3 over 2. For the second part of this question, I need to calculate the value of the inverse function of negative 2. I can use the inverse function to evaluate when my input and my x value is negative 2. So substituting or replacing x for negative 2 is negative 2 plus 3 over 2, which gives me a final answer of a half, or 0.5. On to the intermediate question with an increase in difficulty. Most inverse functions questions have a very similar structure. The only thing that makes them more tricky is the difficulty of the changing the subject that we need to do. The method will remain the same. Given that f of x is equal to 3x plus 1 over 2, we can replace f of x for y, and y is found by mapping x using the rule 3x plus 1 over 2. Since I want to apply the inverse and change the subject, but I want it in terms of x, I'll need to replace x and y. X is equal to 3y plus 1 over 2. I can apply the inverse by making y the subject. Start by multiplying 2 on both sides. 2x is equal to 3y plus 1. Subtract 1 from both sides. 2x minus 1 is equal to 3y. And lastly, divide through by 3, meaning 2x minus 1 over 3 is equal to y. And therefore my inverse function of x is 2x minus 1 over 3. I need to calculate the inverse function of f when my input is 11. So replacing x for 11, 2 lots of 11 minus 1 over 3 is equal to 21 over 3, which is 7. On to the advanced question, one of the trickier questions that you're likely to find on this topic. Not all functions use the notation f of x. We can use any letter, such as g of x. We would still approach this in the same way. Replace g of x for y. Swap all values of x and y. So x is equal to 2 minus y plus 1 over 2y. Take away 1. Now I'll make y the subject. Since y appears more than once, it's quite likely I'll need to use factorising to help me do this. There are a couple of ways of approaching this, but I'm going to start by adding this to both sides, making it positive on the left-hand side, and then subtracting x from both sides to give me 2 minus x on the right-hand side. If the letter that you're making the subject appears as the denominator, you'll have to multiply through by this denominator. The left-hand side will be left with y plus 1, and since I'm multiplying the right-hand side by 2y minus 1, there's 2 terms here, being multiplied by another 2 terms, so I'll need to use double brackets to represent this. Expanding the double brackets so that I can identify the terms that involve my subject, y. Y plus 1 is equal to 2 lots of 2y, 4y. 2 times negative 1 is negative 2. Negative x times 2y is negative 2xy. And negative x times negative 1 is positive x. Isolate all of the terms that involve y I'll do this by subtracting 4y from both sides and adding 2xy to both sides. -2 plus x on the right hand side before subtracting 1 from both sides, and therefore leaving me with all of the terms that involve y by themselves. In this case, I can actually collect some like terms, since I know y minus 4y is negative 3y, and -2 take away 1 is negative 3. This then allows me to factorise the left-hand side, leaving me with y by itself outside of a single bracket. Y bracket -3 plus 2x is equal to -3 plus x, and I can make y the subject by dividing through by this whole bracket -3 plus 2x. So y is equal to -3 plus x over -3 plus 2x, meaning this is my inverse function. If I were to change the steps slightly, and way back at the beginning here I chose to keep this expression involving y on the right hand side and bring everything over to the left hand side, but ended up with 3 minus x as my numerator and 3 minus 2x as my denominator. These represent the same value and would both get us full marks in an exam. Notice how all of the signs are flipped. 3 is negative here, positive here. X is positive here, negative here. It works when you have a division or a fraction, and as our denominator, 3 is negative here but positive here, and the 2x is positive here but negative here. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.